May I introduce the third speaker, Erica, Miss Erica Pellegrino, and the co-author. Erica, are you presenting online or in person? Jose, do you see Erica in the room?
She's online.
She's online. Somehow I don't see her name on the list. So Erica or Dr. Stauhaski, if you're here, please let us know.
Sorry?
So, no, I don't see Erica on the list.
And her co-author, Tanya.
Oh, okay. Sorry about that. Sorry, may I ask what's your name on the list so that I can put you as a co-host? Hello, can you hear me?
No, but I think there's not Erika and Tanya. They are not in the Zoom session.
Okay, no problem. Then maybe may I introduce the fourth speaker first to present first, and when Erica is coming back, then we can ask her to present. So Zhen, Miss Zhen Tai. So I can see that you're here, right? May I ask if you can present earlier? Sorry. I think I cannot ask her to be a co-host. Jose, would you mind to help to make Zhen as a co-host, please?
Okay.
Thank you very much. Yeah, so Miss Zhen Tai and her team are going to present an interesting topic about a case study of digitalizing prefabrication process. So in using RFID and also Bluetooth system. Zhen, can you hear me?
Hello, thank you very much, Professor. I hope everyone could hear me and see my screen. I think so.
Yes, very clear.
Because
thank
I
you very
couldn't
much.
see you right now. Okay, good. Thank you very much. Good morning, ladies and gentlemen. Welcome to my presentation today. I'm Zhen Tai from Technical University of Munich. And today it's my pleasure to present my topic, a case study, conception of digitalizing prefabrication processes in the construction industry. So firstly, I want to give an overview of the content today. I will firstly make a short introduction of the background information of this case study, and then say an overview of the system design of the whole application. After that, I will introduce the implementation and its results. And also in the end, I will give a short summary to this case study and also the outlook of the work. So as we know, construction industry is crucial to the economy due to its high turnover, especially in Germany. And prefabrication is accordingly one of the most useful way to enhance the industrialization progress for the construction industry. The prefabrication enables an offset production of the construction elements, for example, simple construction components like door or windows, and also for the complex building modules, like the example of here and housing module is also prefabric capable. The concept of prefabrication is already widely adopted by the construction industry. For example, the German company Max Modul, which is a subsidiary of Max Bögel Group, has developed prefabrication method for module design and plays a leading role in the housing section with its solid construction in Germany, often in German market. However, the level of digitalization in its prefabrication process is low in comparison with other manufacturing industries. And in this context, the company has reached out to us, and we have conducted this case study together to make a concept to digitalize their prefabrication process in their production plant to monitor and to optimize the production. So let's move on to the overview of the system design of our application. On the hardware layer, we have a 3-layer model. On the hardware layer, we have sensors, code scanners, actuators, for example, and they could gather data in the physical world and transfer the information with a communication modules to the internet or the internet. And in the middle layer, we have a middleware to filtering data, make data processing, and make data storage. And the last layer is the software layer. We have different software components which provide users with different functionalities, such as monitoring and simulation. In our case study, we have focused on the use of sensor in the hardware layer and data processing in the middleware, and also we have a very simple simulation conducted in the software layer. So let's come to the implementation. We have on the hardware layer, we have tested 2 technologies. One is the RFID system, and the other one is the Bluetooth system. For the RFID system, we have the RFID tags tagged on the product itself, and also the RFID reader stood nearby. The reader recorded the timestamp of a product coming and leaving the production station, so that we could calculate the production time based on those 2 information. For the Bluetooth system, we have used the Bluetooth beacons on the scaffold of each production station, and the Bluetooth reader was attached to the crane, which transport the product from one production station to another. Each time the crane entered or left the area of one production station, the time was recorded. It's very sadly that we only test the RFID system in the real world scenario in the fabrication plant due to the corona constraints. So the Bluetooth system we have only tested in our labor in the university. In the middleware, we have also tried 2 different types of data processing for our different systems. For the RFID system, we could only process the data with manually, and we have also filtered and interpreted the data also ourselves. But the Bluetooth system has the advantage that we use the system from one manufacturer called Motion Miners. It could automatically gathering the data and selecting the data and filtering, processing the data. So it's actually much more comfortable. On the software side, we have used the data we derived from the RFID system as the real-world data as input for a simulation model. We have built a DES model of the production plant. This build is simplified because the company doesn't want to give out the layout of the plant, but this is very representative. We have the real-world data of the production time for this crucial component double wall, and we have conducted a bottleneck analysis. We could see that if the production time is of this double wall components is 2 hours, it doesn't offload the whole process. And if the production time goes up to 4 hours, the double wall production will be a bottleneck of the whole process. So in that case, further measures should be taken to ensure the production. So in the future, the data processing process of the RFID system should be automatically done, as well as the data transmission process. And also, we would like to gather more real-world data to support this simulations model and for further improvement of the performance of the production. So, thank you very much for your attention. I'm open to question.
Thank you very much, Zhen. So is there any question from online and the audience, please?
From the audience, we don't have any question.
Okay, then maybe I also ask one question while we're waiting for the audience. So thank you very much, Zhen. I think that the research is very fascinating. So I see that so you took the layout of the factory from the collaborator, from an industry partner. And then also you mentioned that the bottleneck is the production of the double wall, right?
Yes.
Yeah. So first question is, if the process will change, if the layout change, have you guys tested this already? Or and the second question will be about I understand that fabricating the double wall will be the bottleneck. So is there any solution you can suggest?
From the layout changing, I think you mean the fabrication layout, if it was changed.
Yes, because you mentioned in your future research to collect more data, maybe from another company.
Yes,
so, yeah.
Because in this, in my use case, I only collect because we actually somehow know that double wall would be crucial. So we only collect the production time of the double wall. Actually, there are like 17 production stations of the whole system. We should collect we should collect all the data of the each system. It's kind of due to restriction of the hardware. We don't have so many RFID readers, so we only took this point measurement. That's what I mean, that in the future that we should collect more data. Yes, and actually this layout wouldn't change too much because in the companies all manufacture machines fixed on the ground. It's very hard to change. What we could do for the bottleneck is that we could order in more manpower to this station. That would enhance the production process.
Okay, thank you very much.
Okay, thank you.
Professor Chang, I'm sorry, but paper number 47, we think we have a video. So I'm going to look for the video and we can play it right now.
Now.
Yes, the authors uploaded a video and we can play it right now.
Oh, you mean the video from Erica, right? From the
Yes.
previous.
Mhm.
Oh, okay. If possible, maybe we play that video at the end. Is it okay? Because I think it would be good that we can finish all the live presentation and then we play the video.
Okay, perfect.
Okay, thank you very much, Jose. Okay, thank you very much, Zhen. So we appreciate your presentation. Thank you very much.